to chapter 2 video 4, electricity on the move, electric current. So last time we looked at static electricity, how it involved electrons being transferred and creating a charge difference. So now that's all well and good, but static electricity does have its limitations. It's static. So how much better would things be if we can cause those electrons to keep moving, exploiting the energy that's involved in this process? Well, we can. Electric current. Electric current is the movement of charge through a conductor. A current, I, is measured in amps A, and it's equal to the amount of charge that flows every second. The unit of charge, Q, is the coulomb, C. Confusing, eh? The equation that relates the amount of electrical charge that flows to current and time is charge equals current times time. Q equals IT. Now the charged particles that flow in a wire are electrons, which have a negative charge. Now they flow from negative to positive. Ions are positive particles left behind when the electrons move. We say that electric current is the flow of positively charged ions from positive to negative, but ions in a wire don't actually move. It's a convention. So first of all, we need to provide a potential difference. Now cells produce a flow of charge when a conducting wire is connected across their terminals, caused by the potential difference, the PD, between the terminals. Potential difference is measured in volts, sometimes called voltage. Now the flow of current from a cell is always in one direction. It's called a direct current, or DC for short. A battery is a number of cells connected in series. The number of hours a battery will last depends on its capacity in amp hours and the current it is supplying. Now different appliances will take different currents from the same battery. Hours equals amp hours divided by current supplied. For example, a battery is labelled 12 amp hours and it's used to supply a 0.5 amp to an iPhone. How long will the battery last? Well, 12 amp hours divided by 0.5 amps equals 24 hours. The battery will last 24 hours. Now mains supplies have a potential difference of 230 volts. The current supplied by the mains is called alternating current, or AC, because it continuously changes direction. What about energy then? Well, electrical charge flows through a resistor. Electrical energy is transformed into heat energy and the resistor heats up. So the energy transformed, potential difference and charge are all related by this equation. Energy transformed equals potential difference multiplied by charge. E equals VQ. So circuits then, of course, in order for the current to flow, there has to be a complete loop present. Any break in the circuit and the current stops flowing, the circuit just won't work. And current is measured using an ammeter, and the ammeter must be placed in series next to any other components. The current is the same at all points in a series circuit, so it can be placed either side of that component. Potential difference is measured using a voltmeter. Now the voltmeter must be placed in parallel with the component that it's measuring. To sum up then, charge equals current times time, a cell produces direct current, and the number of hours a battery can power a device can be calculated using hours equals amp hours divided by the current supplied. The energy transformed is equal to the potential difference multiplied by the charge. Ammeters measure current and voltmeters measure potential difference. Well, that's the basis of circuits. Now, next time we'll be addressing that perennial issue, resistance. What we mean by resistance, what resistance actually is, and how we can calculate what resistance is in different circuits. So in the meantime, if you haven't already, make sure you subscribe to our channel, click the bell to receive alerts when we upload more videos, and don't forget to look for us on Instagram. If you have any comments, feedback, requests, or just want to let us know you're there, leave a message in the comments below. Until then, keep wondering about the universe. Nice tea.